Okay, so right before the break, we talked about image maps, which kind of makes a nice segue to the next thing. Some points about graphics. So another very common use for markup languages does occur in graphics. What's called scalable vector graphics, or SVG. I'm going to start here. I guess when I say computer graphics, you probably think of what's known as raster graphics. If I share my screen, that's what's here on Microsoft Paint. This image got resized, and there's here on a JPEG image, there's color data for every pixel. That's broken down into a whole lot of pixels, and then the computer just stores the data about what color every pixel is going to be. But then when we go to resize that, I guess I have to zoom out. We can kind of hit a problem because, whoops, everything can do that. It might start to get a little pixelated after we make so many changes. We're going to click, there we go. Select everything and scale this again. You see the picture it starts to get a little bit pixelated because there's only so much data preserved there, and every pixel is separate. It's okay if we make it smaller, because then we just lose some of the pixels. But when we make it bigger, those pixels have to stretch out, and then they don't blend together so smoothly. But that's called raster graphics. It's basically color data for every single pixel of the image. It's also a fairly large file size. And those are the two main drawbacks of that. It's going to be a large file size because we have to save RGB color data for every single pixel. So it's scalably large too. So as our pictures get bigger, our file size gets considerably bigger because there's going to be that many more pixels involved. And when we scale it, particularly when we scale it up, we end up with pixelation. But at some point in a math class, you probably learned about geometry, right? The fact that we can represent shapes with a mathematical formula. And you're probably well aware that computers can solve mathematical equations, right? Mathematical formulas. We can punch in a formula and the computer can solve that. So we should be able to store and retrieve image data based off geometric formulas. That should be kind of an obvious point, right? We know we can have math formulas to represent geometry. We know computers can solve math problems. We'll put that together. We should be able to, instead of storing color data for every single pixel, store a geometric formula and just have the computer solve that formula every time to remember what the picture looked like. And the second part of this intro, y'all probably haven't had a linear algebra class. Has anybody had linear algebra? Matrices? Mostly a whole lot of stuff about matrices. It's probably not, but it doesn't show up much anymore, but computers actually operate off linear algebra. It's all in the background. Since by about the mid-1970s, the actual linear algebra part had all moved entirely into the background, and the high-level programming languages we use are more like elementary algebra, the solve for X type of math class stuff. Right? And we use that sort of thing as an assignment to our variables. So we don't directly deal with the linear algebra, but internally the machines are, well, unless we're doing the internal stuff, setting up operating systems and working directly, making compilers and things like that. We don't necessarily work with the linear algebra, but the machine still uses primarily linear algebra. It's just pretty much since the 1970s, has been pretty much completely hidden from the programmer and the high-level languages. But if we put these two things, those two ideas together, we end up with the optimal way for the machine to do computer graphics, which is vector-based geometric equations. Linear algebra is all about vectors. If you haven't seen those, and instead of numbers come in multiple parts, so instead of just like a number, the standard example involves arrows. We use arrows to represent them, and that arrow is going to have like some length, maybe a length of 4, but also there's an angle that, so we have a magnitude and a direction to it. So there's 2 parts to the value, and those 2 things, we can move that anywhere around our coordinate axis. And if we have something with the same magnitude and the same angle, wherever it's sitting at, it's essentially the same thing, because both parts of the number are the same. And that's the idea of what linear algebra is. It gets a lot more complicated than just 2 very, very quickly, but the values we work with have more than one part to them. They have more than one dimension. So you could think of it like X, Y, Z values. In X, Y, Z in space, we've dealt with those, right? The X, Y coordinates on the thing, and then in our style sheets, we would use that Z value, the Z value to move things forwards and backwards, in front of or behind other stuff. Those are kind of vector spaces, because every spot on the screen then has three numbers describing it. The X value, the Y value tells where it's at on the screen, and then the Z value says whether it's in front of or behind of other things. That's kind of the idea of vectors, but we can use that to describe geometric math formulas. And yeah, like I mentioned there, programmers don't work directly in linear algebra anymore, not since the mid-1970s. So this, the linear algebra part is put together for us. It's there ready to use, and a very common way of working with it is in markup language format, scalable vector graphic format. And we just kind of type in the stuff we need. And all the vector-based complicated geometry equations are put together in the background. They're encapsulated into the thing already, so we can just ask for them in a nice, efficient markup language that'll move quickly through the computer. I'll say that. So I'm going to start a new web page and kind of look at a couple things here. A couple very basic things. So just start basic starter for a page. We've seen that so many times now. You all should have those starting tags down pat, right? Have the head section and the body section. I'm going to call this graph.html. I guess it isn't very much shorter than graphics. I was going for a shortened version of graphics, but and I'll just draw a picture on here, right, which fits nicely with that image map we just saw. With a markup language, if we can do our graphics in a markup language, we can put that directly in the HTML code and then apply an image map to that if we wanted to. And it has certain advantages, particularly the S for scalable. We don't lose anything when we scale it up and down. So like you probably could have guessed, we have an SDG tag where we mark out that we're getting ready to type in some scalable vector graphics. And with this, we always want to give it at least 2 attributes. the width and the height. I'll just do a 300 by 300 box. That'll probably work for a quick example. So that sets up a little box where we can put together the code for some graphics. And we can set up basic shapes. I'm going to do 2 basic shapes real quick, and then we'll go to something better. Because yeah, it takes forever to do this by hand, and we'll look at a better way to do it. But I don't know, maybe I'll stick a paragraph in here too, just that way it's, here's a circle. We'll start with a circle. And in a tag, we have a tag to draw a circle, basically. And we saw with the image map, what do we need to define a circle? How many numerical values does it take to define a circle?
Well, it takes the coordinates for the center. Yep. Do you consider that 1 numerical value or 2?
2. Well, depending on how we look at it, the way we're getting ready to type it in the SVG tag, it is 2. So the CX.
So you need that and the radius.
Yep. So really 3 numbers, the center and the radius. So the center X coordinate, let's say I'm in a 300 by 300 box. So I'll come over 30 and the center Y. And by default, Y on X goes from left to right. So as we move from the left to the right on our screen, the X value increases. And by default, the Y value increases as we go down, which is a little bit different than math class. In math class, you probably learned about Y values going up on the page, but on computers, well, it's like line numbers on a page. The line number increases as we go down. The Y values are kind of like that. And they'll come down 110 pixels in our little block there. And that'll put the circle on there, but we need a little bit more information. Like we need to say what color it's going to be. I'll do a couple colors. Just an outline is a stroke. I'll put a blue outline. We need to say how big that is. Stroke width, 4 pixels. And, oh yeah, I forgot the radius. Sorry, going back a little. The R attribute is radius. That's going to be a common one. So let's say a radius of 33 pixels. And then we'll do a blue outline that's 4 pixels wide and maybe a fill color of sky blue. I think I got all that typed in there. I'm going to turn on word wrap because that did kind of drift off to the side. There we go. So the circle tag, and it has these attributes, the center X, center Y, and radius. Then stroke is used for the outline and fill for the inside. And if we're going to put an outline that's more than one, obviously one pixel would show up. But if we want something else, just a stroke dash width to get how wide it is. I think I got everything typed in there correctly. If I open this up. So it drew this circle right there on the page for us. And then obviously we can use circles to build bigger, more intricate looking shape images. Circles or a rectangle.
Okay, so it's a little bit, it didn't quite make the page because your radius was 3 pixels bigger than your
yes.
Was
so
then your
your
position.
Yes. Maybe I should move that over a little. There we go. That was on the page. Yeah, so you do have to watch things like that, and where it's positioned makes a difference too. Because these are the coordinates in that box. So if we would have centered the box, it would have just overflowed to the right, and we'd still see it on the page. Does that make sense, Joe?
Yeah.
Like a
Okay. And now
SDG element.
now your stroke width, does that go in towards the radius, or is it goes out from the radius? Your stroke width.
Which one?
Your stroke width is part of your radius, right? So
I believe it's included in the radius.
so that means that so that the diameter inside the
let me check. So I'm going to take that line out.
diameter inside is about 58 then.
Yeah. So it looks like it did not change.
Okay.
I took that off and hit reload, and I didn't notice the size change.
So if you did a stroke width of about 20, it'd be real obvious.
Yeah. 24.
Yeah.
Just add the two in
That'll
there.
make it real obvious.
And it should still be this same size. So watch when I hit reload.
Ooh, now wait a
Actually,
minute.
that did look bigger.
Wait a
didn't
minute. Wait a minute. Part of our theirs went off too. So where our whole page kind of went.
Oh, yep. So it apparently is outside that center.
No, wait a minute. No.
Let me take
You're
that off
right.
again.
You're right. Wait a minute.
Take that off. Let's watch and see if the center stays the same size.
Oh.
Nope. It looks like it changed.
It changed too. So that's weird.
It must split the difference.
Maybe.
So, like if it's 24, there's like 12 inside and 12 outside.
Okay, so stroke width splits the difference.
That's what I'm thinking from looking here. So I'm going to change that to 12, and it should. Yeah, it looked like it only affected that outside stroke. So the stroke width is centered around that outermost pixel. Centered around the radius, I guess would be the way to phrase that, right?
I guess I'm not. It's weird that it cut off part around the page when I should have stayed within the page if it was all inside. Okay.
Yeah.
Okay,
yeah,
so wait a minute. So the ultimate is if my radius is 33, if my stroke width is like 30. Because these are all in pixels, right? The 33 is that a
yes.
pixel?
Oh, I don't know why I put pixels there. I don't need. We just need the numbers. It is in pixels. We don't need the units here.
Okay, so if I take an ultimate, so
the stroke is optional. I could take the outline off, right? We don't have to outline our shape.
Right.
So we can put that in there, and then if I make it 6 wide, it should just be a very narrow one.
Well, yeah.
So the center, so it's like the center of that stroke is at the radius.
Right. 3.
Yeah.
So the center line of the stroke.
Mm. Yeah. If you're going to draw with this, we're going to see a better way to do it here in just a moment. So we can also do a rectangle. How many coordinates do we need? How many numbers do we need to define a rectangle?
I'm gonna guess well, you need an x coordinate and a y coordinate for like bottom left, and then and then you need a x and y for the top right.
Yep, exactly. So this one, unlike that one we just looked at, we put in our coordinates. So I'll come over 25 and down, let's see, 110 plus 33. I'll add a couple more, so 147, be right past it. And this time we use a width and a height. So instead of two opposite corners, we have our starting corner and then how wide is it and how tall is it, with positive numbers continuing down. So a width of maybe 50 pixels and a height of 30 pixels. Oh, and then we need a color. I'll just do a fill one on this. Fill this one with green. And yeah, we could leave off the stroke or the, if we don't want an outline, or leave off the fill if we just want the outline. Kind of mix and match them. Then that gives us that little rectangle. So we have that starting point, and how wide is it? So 50 wide and then 30 tall. And what do you think is going to happen if I put a negative here?
It's going to bring it up. It's going to go up instead of down.
It just errors out. That was a good guess. That is exactly what everybody expects to happen. But that's why I explicitly wanted to show that. It just errors out. So we can only go from the top left corner. We can't choose a different corner. That makes sense?
So the starting corner is top left.
Yeah.
Top left, okay.
Only use the top left corner, and then how wide and tall is it from there? That gives us a couple shapes. Right. And some words. Here's a circle and a square. And another thing, we have those coordinates exactly, so that fits really nicely with the image map thing we just saw. And we can also have polygons and a bunch of shapes that we can use. I'm just going to point at them. W3 schools SVG. Oh, I searched it this morning just to make sure it would be at the top of the list. So there's a tutorial on SVG if you want to go through and look at that. We have rectangles, circles, ellipses, lines. Polygon is lots of sides. Polylines is like a polygon, only it doesn't close up at the end. Whenever we have a polygon and polyline, coding them would look almost the same. We'd have the same number of points, but the difference is the polygon would actually add that last line to make the shape close up. Different paths, so we can explicitly say stuff, some effects. Y'all can look through those if you want to actually draw with it. As a much more common thing is, well, it's just a markup language, right? And earlier, when we were talking, I was talking about XML languages, I pulled up a couple examples of some scripts that I have laying around where the code was writing the markup language for us. So obviously we can do that a whole lot. We can set up some things a whole lot nicer than typing all this in, where we drag our mouse around and then it writes all the code in the background. In particular, that's why I have this software open. This is one called Inkscape. This one I use quite a bit, it draws SVG shapes. So if I grab a little thing, I'll just kind of, I'll just put a quick picture here together. I grab the tool for a polyline, or to just kind of start drawing lines on here. And then, so that's a polyline. And when it closes up, it's a polygon. You can see it turned into a whole shape, and then we can add some fill colors, some kind of skin looking color, and turn the stroke off on it. And then I can come back here and draw some more. This software is set up so it kind of snaps right in there. It snaps right to that edge. And I can, whoops, undo that. Should snap right to that edge. And I can come through and put a bunch of shapes together. Get the shape there, turn off the outline, set maybe red fill on that, and just build these things up this way. Come in here. Do something like this. Fill that with that skin skin color again and turn the outline off. And I think y'all can see where this is going already now, right? And have a lot easier to draw things like this than type all that code in. Turn the stroke off, and I'll fill that with like a dark blue. There we go, something like a character. And
And you can move that one to the front, can't you, your arm?
Yep, that's what I was getting ready to show. They're all independent. Whoops. Escape out of that. If I come over here and click on the little arrow, I can click different things. They're all independent of each other. Click the arm and raise all the way to the top. Yeah, put that in front of the other stuff. Or here in this particular editor, I can hit Control-Shift-X, and you can see here's the code that it was writing. Behind the little thumbnails, so I can move that out of the way. If I click on the node, get different things about it. I have different IDs for each one, things about it, what layer it's on. But there's some SVG code involved, and there's selectors and CSS. Those titles should look familiar, right? So when we click on things, we get a bunch of CSS properties about it. Identifiers and the style sheet things that are used for that particular CSS. Yeah, so we didn't see that, but we can, just like the rest of the tags we've been putting on web pages all semester, when we put in SVG tags, we can style them with CSS as well. But all that's written in the background with this software. If I go and save this, well, I'll just save it as drawing. I don't really need to give it a good name. And then I come over here and oops, I can open that with the text editor and see, well, you can see right off the bat, it draws it in XML format. So a little bit different than the example we just looked at. You can see a bunch of tags that we might not know these tags, but we know what tags are, right? We've been looking at a markup language for the past 7 weeks. Metadata about that, we could add that in. Yeah, I used Bezier strokes, so it just gave this. They were all lines. Does anybody remember lines from math class? Your y equals mx plus b. So all those lines put together, and there's the comma separated. There's the slope of the line and the y-intercept. So there's the two numbers to define a line. And then the next line on that shape, the slope of the line and the y-intercept define that line. And we get all those in slope, all those combinations, and some other data, which we could just type in there, but it's a whole lot easier to move our mouse around and let the computer type it. And then we get that fill information. Well, they did it all in CSS here. The style attribute with fill is this, stroke none, stroke width, line cap. Stroke line cap is the corners. Do the corners like butt up against each other? Are they chamfered or filleted, or the different ways we can put them together? The corners butt up against each other with a miter joint, the way it drew it, and all that information that we could type in, but it's kind of put there this way. A little bit easier when we use the software. That one I was just using, this is called Inkscape. It's open source software, so it's free to use. It's written in C++, but it has Python wrappers, so you can do scripting in Python as well. Or if you want to customize that open source code to fit your own needs, you can use Python, either Python or C++ code to adjust it. You can write custom scripts in Python, which is really nice, and that one's free. Obviously, there's an equivalent Adobe version that costs a lot of money. Adobe stuff tends to cost a lot of money, but that's one that I've been using for a while and have been really happy with. Has lots and lots of features with it. But if you want to give that a try, just look for Inkscape. It's a very popular one, so it's probably at the top of the search results. Yeah, if you just inkscape.org, it's open source product, and kind of a nice one. Then we have that SVG, which we can open with our browser directly. Somewhere, here it is. Open with Chrome. And then get that picture right in there very quickly. Or we can, it wrote all this code for us, so we can just copy and paste all that code and put it into our HTML file. So from that opening SVG tag down to the closing SVG tag, I'll just hit copy and paste that in here. Maybe put in another paragraph. Here's a more detailed shape. And paste in, just paste that SVG tag right into this HTML file to get it on here. And it's just more control over our graphics. And those 2 points that I talked about introducing this, it's not pixel by pixel data stored in the computer. It's just an equation. It's just a series of equations to represent that shape geometrically. So the computer doesn't take up as much storage. You can see right here, it's a text file. It's equivalent. It's equivalent to just writing up a text file, because that's all it is. It's just the numbers the computer needs to calculate the geometry for the shape, which means we can also scale it in and out without losing anything. It won't pixelate on us. Well, out's not really a problem, but when we scale in, how big can I go? Yeah, like 500% in. Notice that that little bitty circle and square we drew didn't pixelate at all. There's still that super crisp edge between the fill and the stroke line. And same thing on this picture. We still have that super sharp point, kind of what I was thinking, the nose when I threw that character together. We don't get any pixelation because it's just an equation describing that picture, which is sort of the biggest one, because we have no idea what sort of screen size people are using, right? Might be looking at it on their phone, or they might broadcast it to their TV, which would be huge. So being able to scale our graphics in and out without losing anything can be really nice. So you can play around with those different shapes if you want to try coding them up. It can be really, really fun. What did I type in? I searched W3 Schools. I just searched W3 Schools SVG, and that went right to the tutorial and see all the shapes we have to work with. I find that really, really fun. It can be a little time consuming to do it all manually, but it's like art with math. You're thinking about a math equation and typing in all the numbers and things manually and with these different shapes. Or as far as open source software, this one I've been using for a while, Inkscape. It's got a lot of other features too. We can convert it into different things. This one can take a PNG file and convert it back into SVG graphics, convert these things to bitmaps. if we want. But it's free and free to use and open source, and it provides a good way to get graphics to put into your web page. Which again is just done with a markup language, because that is the optimal way to move data through a CPU, through the central processing unit. We have our start point and our end point clearly marked, and then the same thing with the data inside of it. It works really well for a CPU. So another alternative for putting images together and kind of end up with things a little bit better than we could get in Microsoft Paint, especially since it's scalable vector graphics and not raster graphics. Any questions about those? Okay, so that's something you might want to look into, and yeah, obviously, if we're doing that, let me share my screen again. Even if we have the computer generate it, like it did that down here, we have all those coordinates. So it works really, really nicely with that image map stuff, because we have all those coordinate pairs that we would need to put the image map together. We could copy and paste that stuff into an equivalent shape in the image map. And so it works pretty nice for that. So if there's no questions about that, I did have a couple more useful HTML tags to look at that didn't really fit into any of our lectures this semester. I guess I can go back to sharing the screen. I'll set up another, whoops. Set up another one real quick here. I had starter files at one point back. I think actually more than once I had starter files, and I stored them in my delete folder, I think, and just kind of deleted them without even paying attention. What's next? Domain. So I think I'll start with an example here of why this next one would come in useful. So maybe we're putting some site together that is going to be connected to Ivy Tech. So we're going to have lots of links going to the ivytech.edu domain. And I'll just put some in a little list here. So you don't need anything too fancy, just some links. But maybe list item, and put some sort of something in there in a second. Like something about jobs at Ivy Tech. And if we need to link to that, we'd want to put in that whole the domain to get there, right? HTTPS : oh, my computer freeze up. There it goes. Hypertext transfer protocol. Then www.avtech.edu/ what is the address? I have it in my example. I think it's jobs.html. In my example, I just have jobs typed there. So, but let me see if that's the right link. When I put my example together, because I'm looking at it on my tablet here, I just typed jobs, but I guess I don't need the HTML. Oh yeah, that one loaded. So we could do that. I'm turning the word wrap off. And maybe just go full screen. There we go, that'll all fit. And then some other, maybe we have a whole bunch of links on this page all going to Ivy Tech, right? It's the page on our site that connects to Ivy Tech. So we have a whole bunch of these links. What's next? href equals something I'll come back and fill in, and programs at Ivy Tech. List item, and then that one would be HTTPS : the / just indicates a protocol. You'll see that a lot as you progress through software development courses, because we often need different protocols. But anytime we have a protocol, you're going to have : / then in this case an address, www.ivytech.edu /programs -a-z /index.html. I think it's that link there for us. If I open this page, it's probably what you expect. Just a couple links here. One of them goes to the jobs available at Ivy Tech, careers available here at the school, or another one is the programs, the degrees that we can study here at Ivy Tech and all the different campuses around the state. But like I was saying, maybe this is the one page on your site that has all the Ivy Tech connections. So that means every link on here is going to have https : www.ivytech.edu, because that's going to be a different domain than our website, which means we have to use absolute addressing. Except we don't have to use absolute addressing. The next tag I want to look at makes it so that we could do this with relative addressing on this page. And that's the base tag. It goes up in the head section. And basically what it does is it tells us what the base URL for every link on this page is. So since every link is going to have this https : www.ivytech.edu, we can call that our base. We do want to set the target attribute, where we can set that to at blank to open in a new page, and then set that as the H as our general hyperlink reference. And then we don't need that in any of our links down here, because that base tag means that every link on this page goes to this domain, not our local domain. Did I say that correctly? I think so. I hope so. So it still looks the same. But the difference is when I click jobs, it still leaves our domain, which in this case, that was just locally here on my machine. But I used relative addressing. I was able to use relative addressing and access these links on this other domain. So if your website has a lot of links that go to another domain, this can be incredibly useful. Then you don't have to keep typing those absolute addresses. It does go for the whole page though, so you do have to organize it to a page by itself. But it can be useful. Yeah. So Then we can use relative addressing everywhere. What else do I have on here? Apply -now /index.html. Put one more in there. Again, just relative addressing, saying how to get there from where we're at, but we already told it that every link on this page needs to jump over to this other domain. So that's one that might be useful for you. I've never used it extensively because I just scatter the links around and I always copy and paste them anyway. But I guess I can see situations where you would have a whole lot of links all going to the same thing if it's very connected to your website or something. Or maybe you're at a company that has an internal and an external network. And so some of the web pages need to access the different network if people have access to it. What time is it? 3:15. So the next one I had in mind here, I'm just going to copy and paste this. Copy, create a new one, paste this, and clear this back to the starter thing instead of retyping that every time. There we go. That's like the starter file. I'm going to call this backwards.html. So this tag, I'm not really sure about this tag. It has existed since for as long as there's been HTML. So there must be a use for it, but I've never actually found a use for it, but maybe you'll find a use for it. So these words go forwards. And the tag is the BDO Bi-Directional something. I wrote it down. Bi-Directional Override. The Bi-Directional Override tag allows us to say which direction the words go, left to right or right to left. That's our two options. It is dir. And it has the direction attribute, which is either RTL, right to left, or LTR, left to right. I'll do RTL. These words go backwards. / bi-directional override, and in the paragraph. And if I pull this up, you can see, even though I typed that forward in the text editor, the word, it turned them around. I've never found a whole lot of use for that tag. Maybe you'll find use for that tag. Actually, let me jump over to my drive and grab this example that I pulled up. The only time I've ever come up with a use for it was the example I'm copying from today. So let me download that here. Oh, maybe. My button. I was just going really, really slow. Oh. There it is, download. The buttons all came up behind the little thumbnail images. Open there, file, save as. Oops. That's not what I meant to do. Save as, yeah, so last year when I taught this class, I was really bored in office hours the day before the class ran. So I did come up with this for a use for it. Try to make it look like a mirror. Objects in mirror closer, and then turn the text around and kind of send it off sideways so that it kind of looks like a mirror, but it's still not quite correct because the letters aren't turned around. They just get wrote backwards. So I have never come up with a use for it, but it has been around since the very beginning of HTML. So there must be a use for it, and perhaps you'll come up with some sort of use for it for mixing your letters around like that. And we can go, it does go both ways. So our regular text, we can also put in a BDO tag, and direction equals left to right. I guess it might work if you wanted to embed something, right? What's a language that goes right to left? Doesn't Yiddish go right to left? Does anybody know? I can't remember for sure, but I think they do. So maybe if you
I think it's Hebrew. I think Hebrew does.
Yeah. Yeah, Hebrew goes right to left. So I think so. So if you're writing most of the page in English, it's going to try to write it left to right. If you wanted to put some Hebrew, like a line of Hebrew in there, you could use that to turn it around. That just popped in my mind. There might be better ways to do it, but yeah. This BDO tag has been around since the beginning of HTML. So there must be a use for it. It's still included in all the later standards, but I've never personally encountered that use. I just thought I'd show it to you all. That way, if you do ever come up with the use for it, you'll know what to do. And your options are either LTR or RTL, left to right or right to left. Let's see. Whoops. Copy that. Make a new starter file here. And save this as math.html. So this is that other thing I'd mentioned earlier. We can set it up to do the math directly here. It's really scripting that we put in here, but it varies from from the way we would normally script stuff. It's not quite like JavaScript. It's very similar to it, but it's a little bit different. So I'm going to put a form element together with a couple of inputs and an output box. So, and then we'll come back and see the math part. So I have an input. I'll give it the ID of X, using X, Y, and Z for our math numbers. Type equals number. Anything else there? Maybe a default value. Value equals 0. And then another one, input ID equals, call this one Y. Type is number. I'll stick a default value in there. And then along with the input tags, we also have an output tag. And I have never used the output tag for anything other than this. And this isn't something that normally gets done a lot. We usually do this in scripting. So I usually use like inner HTML on a regular tag so it can be styled and stuff. But we do have input and output tags. And our output needs a name attribute. So I'll call this V, and it's for X and Y. Anything else there? Nope, just the closing tag. So it looks a little bit different. We have the inputs, and both of those need IDs. And then our output gets a name, and then the for attribute uses those two other IDs in the form. And then we can end the form. I put paragraph tags in here. I guess I could fill this out a little bit nicer with like a paragraph tag, just to make sure there's a line break there. And to start with, I'm just going to add those. So that first input plus the second input equals that. So when I open the page, we should see those signs. Where did I save that at? There it is. Yeah, so we have input plus input equals, well, a blank thing right now. And in our form, one of the things we can call, you may recall I mentioned very briefly when we were kind of previewing the scripting stuff, that all of our events, that's things that can happen, things that we're waiting to happen to run code, a lot of them are built in. One of those is on input. So when the user makes an input, we can have something happen as a string. And that is, we can refer to these things. So we have X, Y, and Z here. So we can say like Z dot value is assigned parse int X dot value plus parse int Y dot value. Anything else? Nope, I think that's it. So it just kind of adds them together, and it looks similar to what we saw in JavaScript when we looked briefly, right? We have to make sure and cast that as an integer so we don't get confused. The computer doesn't get confused about what a plus sign means. But we're missing a lot of that other stuff we saw in the JavaScript preview. In particular, all of that document.getElement by ID, those big long strings of text, we're just immediately referring to this name on the output and then these two IDs on the inputs. We can refer to them directly and then just do some basic math with them. Now, if I reload that page, when I start typing numbers in there, so like 3, well, right now it's 3 plus 0, it shows 3, but as soon as I put a number there, it starts adding that up. So every time there's a change to that input, it automatically adds those together. So that's kind of how we do math in right in the HTML. And you can see it's possible. So it's possible to do it. It's not the most feasible thing. So the last thing I wanted to do was something a little bit more complicated than adding, just to exasperate that not most feasible, because that's not too bad, right? It all fit in one line there nicely. But I'll add some labels. Each one, this is adding with HTML. And I'll add another label down here. H1 is a here. So again, we'll need a form element that has our inputs and our outputs. Oh, I guess there is a tag we haven't seen here that might be useful. Again, I'll wrap these in a paragraph just for good measure. Make sure they're all on one line. Then kind of write out the Pythagorean Theorem. Does everybody remember that from school? About right triangles. A squared plus B squared equals C squared. So we could write that. So like, I'm going to put some parentheses, which is just text, right? There's a paragraph tag, and then we start into our text. So that's what that parenthesis is, not part of the coding. That's just text to show there. An input is type equal to number, ID equals A. Do I need anything else there? I think that was all I had. Oh, I might want some small ones. So step equals 0.001. Make sure it's not integers. I'll use some floating point numbers so we can go down to small numbers and still be acceptable. And the default value of 0. I'll close the parentheses, and then one we haven't seen yet is the SUP for superscript text. We have a superscript and subscript. Obviously, subscript is SUB for sub and SUP for super. And then we can just put that to there. Went behind the pictures. Did I get that? Yeah. That plus the Pythagorean Theorem. So I'm just going to copy all this. So copy all this to this line. And again, we want a superscript to indicate squaring. So I'm going to put sup2 in that one. Then equals, and then I'll put the output. An output tag with a name instead of an ID this time. So our inputs need IDs, and our output needs a name. I'll call it C. It's the output for A and B. And that's all we need to put there. So in the output tag. Oh, and then since we're writing the Pythagorean Theorem out, we need a superscript 2. Just to see what that looks like. So if I come over here and reload the page, you can see that we have that input box squared plus the other input box squared gives us the output squared. So A squared plus B squared equals C squared. And then all those things we saw with forms still apply. Like you could change the colors, put the placeholder text and things like that in there. And then in the form, we do on input equals the math that we want actually carried out, which is C dot value equals, and put spaces in here. So we have to call in the math library to get to our square root. So math dot square root of A dot value times A dot value. So A squared plus B dot value times B dot value. A squared plus B squared. Did I get the parenthesis on the end? It's fine, pictures. Okay, yeah, I think I got everything there. You see, it starts to look a little complicated pretty quickly. When do we first learn the Pythagorean Theorem? Like 4th or 5th grade? It seems like an elementary school thing, right? But it starts to look kind of complicated if we try to do it all in the HTML. Where in most of our scripting languages, it's not too bad. So if I reload that, let's see if that worked. If we put in a 3 and a 4, yeah. So 3 squared plus 4 squared is 5 squared, or 9 plus 16 equals 25. Mostly, I wanted to show this last one here just to show that it is possible. If we have a method by which we can give a machine instructions, then in theory, we can give that machine any instruction that it could accept from that method. So we can do things like this. We can do math in our HTML. Or next week, we'll see putting text on the web page from the style sheet, or doing a little bit of math in the style sheet. So it's possible, but it's not feasible. And it starts to get very cluttered up very quickly, right? Like just getting our numbers takes a lot of different things, and we want to format them together and stuff. So mostly I just wanted to show that one to demonstrate that it's possible to do that right here, but it would just make a whole lot more sense and be easier to follow and work with and just deal with in general if we had, say, a JavaScript file that ran these two simple, that did these things, and then echoed the results back to inner HTML of some paragraph tag or something. So it's possible, but it's not very feasible, and it gets very cluttered very quickly. I just wanted to show that it can be done. Might as well, before we end, might as well show that last one. We saw the superscript, so I'll put just a paragraph down here that has some sort of a subscript, like the standard T sub 0 / sub is pronounced T not and refers to the start time. Oh, there's someone behind the pictures and I lost track of what key I was on. Yeah, and indicates the start time. So sub for the little subscript things. T naught, T0, or usually pronounced the Old English T naught for the starting time. But this, we have that subscript and superscript if we need it. That's something you might end up needing to be a lot more likely to use than the math one, as far as useful stuff on this particular example. I just wanted to show it's possible, just not very feasible, even for simple equations like that. That's probably enough to tell it's going to get very, very messy very, very quickly. Is that everything I had on the list for today? Yeah. So any questions about the stuff from today? All right, I'm going to assume that means no questions there. So as always, you're probably going to play around with it. The biggest thing from today that you're probably going to want to spend time playing around with is maybe the image maps and that SVG stuff if you want to. It can be a little time consuming, but I find it can be, I have a whole lot of fun doing the manually typing that stuff in. It's like art with math. But that software that I pulled up, Inkscape, that's an open source, free to use one that'll just write SVG graphics for you, and it has, it's very, very extensive. It has lots of features. All the features that you would need to typically do artwork on a computer are available, and it will just write the SVG graphics for you, and then you can just copy them and place them, copy them and use them in places where you want to use SVG graphics. Or generate things from it, the .png files, it works for that too. Lots of features there, so if you want to mess with that, it can be useful. But the big thing today was those other uses of markup languages. That's why everybody has to take this class, even those who aren't planning on doing anything with web design or development ever again after they finish the course. If you're doing software development, it's required because you may not do web stuff, but you will use markup languages somewhere. They're great for the machine, and great for the machine is there's a trade-off. What we normally do is great for the human because it's easier for us, and we're the ones that made that choice. But great for the human or less work for the human means more work for the machine. So that's where we mostly tend to use markup languages in software development, is buying back some of the efficiencies that we lose when we do the stuff that's better for the human. Because markup languages are better for the machine. If there's no questions, that was all I had for today. So about an hour and 10 minutes left of lab time. So it's a good time to finish up homework or work on the projects, because we only have a week left of class now. 2 more lectures next week where I have a bunch of odds and ends and things that might be useful for you. Hopefully they'll be useful for you. But yeah, I guess that's it for today. Everybody have a great weekend, and I'll see you next week. Unless there was another question, I'll ask one more time. All right, have a great weekend. If you have any questions, let me know. As always, I'll be sitting right here till 4:50. And well, as soon as the clock hits 4:51 today, I'm probably taking a walk because it looks really, really nice outside. But otherwise, you can hit me up with questions anytime as normal. So, but for the next hour, I will still be sitting right in front of my computer right here with the video and lights on. So I will see you all next week.